All right, I think it's time for us to start. So thanks everyone for coming to the deep dive session for Cloud Provider Azure. My name is Pengfei. I'm working in Microsoft Azure, and I'm mainly focusing on improving the Kubernetes experience on Azure. So we are very glad to invite Brandon to come to this session and give us a talk about Kubernetes on public cloud. So let's welcome Brandon. Okay.
Go to the side. Does that go to, no. No, I can totally do this. Does that work? Oh, there we go. All right, cool. All right, here's the, this is the agenda for this. Thanks so much for coming and trekking out here and finding it on short notice. And thanks to the audio folks for getting it set up on short notice. Appreciate that. I'm going to talk about the past, present, and future of Kubernetes on public clouds. And then Pengfei is going to come back and give an update and demo of our work. Is that still? That's still coming out? Yeah. All right. On moving the cloud provider out of tree with AKS Engine, talk about how you can get involved, and then take any Q&A that you might have. All right. But first, I want to give a brief history, not a brief history of time, but a brief history of cloud providers. I think that this is an interesting part, because when I look back historically into the context of the world that we were starting within when Kubernetes was getting started, one of the most interesting decisions that was made was a level of deep integration with cloud. And it was really, in part, I think, because it grew out of people who were building cloud, but also a realization that the tools of the time, when you looked at the chefs and puppets and salts, Ansibles of the world, while they were thinking about cloud a little bit, they really weren't thinking about it in what I would call a native way. And the truth is that Kubernetes itself was very much built to be run inside of the cloud. It wasn't built to deploy software that might happen to be running on the cloud. It was really built to run inside of a cloud. And in fact, in early days, the goals in some way were to make the cloud easier to consume for developers. I think if you look at the earlier cloud APIs that existed out there, they were very infrastructure oriented. They said things like virtual machine, virtual disk, virtual network. Those aren't primitives that developers are interested in. And so when we look at, I think when we took a look at designing the APIs, in some ways we were actually trying to refactor the cloud APIs that we saw to be things that were more developer centric. But it turns out that in doing this, we actually really kind of assumed the cloud in many respects. And I think that this was the place, the most interesting place where we first ran into this was in the networking environment. So Kubernetes early on made this interesting decision, which was that every single pod in the cluster would have its own IP address, right? And in many places, as we designed the system, we thought, hey, you know what, we need to meet people where they are. And in a few places, we made very opinionated decisions. This was a very opinionated decision, and it basically was horrible for every on-premise network provider, right? So in the early days, when we were starting to talk about this to Kubernetes, people would say, oh, great, in a cloud, in Azure or anywhere else, it's relatively easy for you to dynamically say, hey, I want to add a route. I just want, for this sitter block, I want all the packets to go to this place. But for these physical environments, it was actually quite challenging. And that is why you saw people like CoreOS starting to design things like Flannel, which was really designed to be a network abstraction that could give a cloud-like cloud-like routing to physical environments. And so, in fact, in building Kubernetes for the cloud, we actually built something that was a little bit hostile to the physical data center. Fast forward 5 years, and we've both networking providers have stepped up a little bit, but also enough things like Flannel have been built and other sorts of CNIs have been built, that it's a lot easier than it was. But I think it's interesting to look back and actually say that in the view of integrating with the cloud, we actually kind of pushed away the data center. And that's actually, I think an important lesson, that no matter where you sort of build for your natural biases, no matter where those happen to be, whether in cloud or not. I think what's also interesting is that Kubernetes itself was built by cloud providers, right? I think if you look at all of the other examples of software in the orchestration space, it was mostly built by people operating software, not necessarily by people providing the cloud. And I think that this changes the perspective. Obviously, people like Red Hat brought a lot of energy as well, and they're not necessarily a cloud provider, but a lot of the code that came from Google and Microsoft and Alibaba and other people who were really building a cloud. And that, I think, changed the way that the APIs were shaped. And then I think also, interestingly enough, we have sort of flipped around to a point where we're actually mature enough that we're actually taking back from the cloud. And so in the work that we are doing in the Gatekeeper project to bring policy to Kubernetes, we're actually looking back at things that are being done in, say, Azure policy, and looking back at lessons learned around RBAC, around how do we do network firewalling, and applying things that had actually already been built in the cloud and APIs that our customers said, hey, you know what, we miss, as we go into Kubernetes, we miss having policy. We miss having network firewalls, bringing those things. We miss having RBAC. I mean, Kubernetes was built without RBAC when it first started. These are fundamental characteristics of what is needed to be in the cloud. Let's take and be influenced by the way that they were designed for the cloud and bring it back into the Kubernetes project itself. And so, interestingly enough, not only were the cloud providers building it, but actually the project itself has started to look back at things that were part of, if we had started out by saying, hey, we're going to change the cloud, we've actually now gotten to a place where we're saying, okay, what are the things that we should have brought along with us as we build forward on top of the cloud? But as much as Kubernetes was built by and for the cloud, it turns out actually that the cloud wasn't built for Kubernetes. And especially in the early days, but even to today, we have seen countless examples of assumptions that we made around the way that Kubernetes works that don't necessarily match with the assumptions that the cloud providers made. And I think the first place and most obvious place where this happened, and continues to happen at times, was around disk mounting and unmounting, right? So Kubernetes assumes, hey, I'm going to create a container, I'm going to mount a disk to it, I'm going to delete the container, disk is going to move. No cloud API was built for this, right? Every single cloud VM API was built around the idea that you created a virtual machine, you attached a couple of disks, and then you let it run forever, right? And ever and ever and ever. And you weren't constantly ripping disks on and off of machines. This is both in the hypervisor stack as well as, honestly, in the Linux kernel itself. So I don't remember I don't know how many people were out using Linux when USB, was just coming in, plug and play was just coming in, but every single time I plugged a disk or a keyboard or a mouse into a Linux machine and then removed that plug, you gave a little silent prayer to the kernel that it wouldn't hang on you, right? Because the kernel hadn't been built for it, right? The kernel hadn't been built for the idea that somebody would be ripping mice on and off a computer, that somebody would be pushing disks on and off a computer. And the same thing was true in the cloud, right? And so in every cloud provider, we've seen challenges with disk attach and detach. And honestly, of course, with the Azure cloud provider, we're still optimizing that path, right? We're still doing work to ensure that the expectations of Kubernetes around how infrastructure is expected to behave match up with the designs that people take into account when they're building out that infrastructure. I think another place of this, similarly for load balancers, right? We've had clouds where load balancers took 20 minutes to create, right? And creating a load balancer in 20 minutes is fine if you create it once a year and you never change that load balancer ever again. But in a world where services come and go, where you're creating load balancers to do continuous integration tests, which is what we were doing at the time, it's just not okay, right? There's this expectation around a very, very dynamic API So if cloud was a little bit dynamic, Kubernetes was really dynamic. And I think what we've seen over the last 5 years is that cloud providers themselves have had to step up, and Azure is no exception. Cloud providers have had to step up and improve the way they deliver APIs. But the good news for the cloud providers is actually that everyone else is going there too. It's not just Kubernetes that is driving this demand, although Kubernetes drives a very significant fraction of all API calls that end up on Azure and probably on other clouds too. It's also actually the same thing that other people are doing when they're doing continuous delivery systems, when they're doing all sorts of other kinds of online activities. The control plane for the cloud is actually no longer really the control plane. It's really becoming as essential as the data plane. But as we push forward into cloud providers, there was actually even more problems. So the next thing we ran into was that not all clouds look the same. Like you squint at the clouds and you're like, well, yeah, they pretty much look the same. And then you get into the details. And it turns out that, for example, one of the cloud providers out there doesn't give you IP addresses when you create load balancers. It gives you a CNAME instead. Right? You get a DNS name when the rest of Kubernetes had assumed that when you created a load balancer, you got an IP address. Seems like a small difference, but it actually has significant ripple effect in various places if what you were expecting was an IP address. Suppose you were programming DNS to do, suddenly you have to use a CNAME record instead of an A record in order to program DNS. And again, Kubernetes has been sold on this notion that it's portability, right? It gives you portability and abstraction above the clouds, but the clouds have this way of leaking up and leaking through into the cloud provider itself. Another example is things like IPv6, right? Cal just gave a great talk about IPv6 and dual stack support in Kubernetes. Not every cloud provider supports IPv6. Azure does, but not every cloud provider does, and I imagine as they do, it's going to look a little different here and there. And so I think these are the places where we continue to see challenges trying to figure out where do you draw the abstraction line, right? How do you say, you know what, it's okay that there are these little differences, and yet still give people a single unified interface they can program against? Disks are another great example, right? In some places, disks can be attached write-only, or disks have to be attached exclusively to one machine. Other places, a disk can be attached read-only to a bunch of machines. That changes the way people build and lay out their Kubernetes clusters. So there's all of these challenges as you start looking at how do I build a Helm chart that can run in every single cloud if there are these different characteristics depending on the cloud, right? So these are all places where this notion that you could have a cloud provider abstraction and just have everything magically work have sort of broken down historically over time. Then one of the biggest problems that we've run into lately, both in the Azure cloud provider and honestly elsewhere, is throttling, right? We have run users out of API quota on every single cloud provider out there, right? Over time, I expect this is a recurring theme until the clouds actually come to a place where they can provide effectively infinite capacity, right? Again, what you're seeing in the cloud is that the cloud was built for people using CLIs to occasionally create resources. It wasn't built for automation pounding against it 24/7. And so we're having to change and adapt the API infrastructure that we build in Azure in order to be able to support the notion that across the world there's going to be programs that just wake up every minute and check to make sure that disk that was attached a minute ago is still attached to a virtual machine. Right? That's a very different paradigm than what people are used to, and it continues to be a challenging one for us to work through in a variety of different contexts. And then finally, there is this problem in Kubernetes itself, which is that the cloud provider code is deeply attached to the Kubernetes binaries that are built. This means that improvements to the cloud provider, like we've built for the Azure cloud provider, are tied to Kubernetes releases. It means that we have to cherry pick fixes into an old version of Kubernetes in order to make those fixes available to users on the Azure Kubernetes service. It means that we can't, do weekly releases. We do a weekly release of AKS. We do a weekly release of the Azure Kubernetes service, but we can't do a weekly release of our cloud provider code. right? So we've been limited in our ability to be agile by the fact that this design decision was made to tightly couple the Kubernetes code base with the cloud provider code base. It was the right decision at the time, right? We favored install simplicity. We favored the idea that you could install one binary and it would all just work. We could distribute one binary and it would work. We wouldn't have to distribute a Kubernetes binary and an Azure binary, or a Kubernetes binary and a GCP binary. We wanted it all to be together, but now as the project has scaled and the demands of updating this code has changed, we've been forced to consider the consequences of that decision about combining things together. And so we're in the process of breaking things apart and providing for an independent cloud provider as a separate binary that can run independent of Kubernetes. And that's what Pengfei is going to show in just a second. And that is the future of the way that we are going to be able to deliver updates to the Azure cloud provider every single week, tied to the releases of the Azure Kubernetes service itself. I think that the most interesting thing, the consequences of what we've found, is that in the last 5 years, we've gone from the clouds saying, why are you treating our APIs in this way, to people actually building features within clouds specifically around capabilities of Kubernetes. So, just as a concrete example, we have Azure Networking building new features for us to light up private clusters for the Azure Kubernetes service, right? So we're getting to a place where supporting Kubernetes in Azure is a first order requirement for our API teams. We have disks, we have people working on storage and disks saying, what do we need to do to make disks that are natural for cloud native microservices? What do we need to do to improve attach and detach times and things like that? So we've gone through this amazing transition, I think, not just in Azure, but really in all of the clouds, where there's a realization that supporting these patterns is not something that we do sort of grudgingly, but actually something that we do in tight conjunction, in partnership with the teams. We've seen a really great partnership develop between the virtual machine scale sets team and the Azure Kubernetes service team, delivering together solutions for Kubernetes that work well for our customers. And then finally, we're actually seeing the cloud do innovation. So recently we announced this service called Teleport. It's just a part of the Azure Container Registry, which enables you to do zero pull, zero download image container starts, right? So you can actually start up a container nearly instantaneously, no matter how big it is, because you're no longer forced to pull an image across the network to get it to a machine before you can start running it, right? So that's, I think, a great example of how we're not just innovating in our APIs, but we're actually innovating in partnership with Azure Storage in our infrastructure to actually change the way that people experience Kubernetes. And that's something that would have not existed 3 or 4 years ago. I think the other interesting piece of this is that the cloud is also starting to build on top of Kubernetes. So when you look at things like the Spring service that was recently announced in Azure, there's a Spring Boot platform where you can bring a Java app, have a Spring experience. It's built on top of AKS. It's assuming Kubernetes as a building block on which we're going to deliver higher level services. Similarly, with Kubernetes at the edge, SQL Server is saying, hey, if you want to run a big data version of SQL Server, if you want to run SQL Server in Linux, we're going to just assume that you have Kubernetes out there, and we're going to start delivering cloud-based services on top of that Kubernetes cluster. So we're starting to see not just that Kubernetes is being built in conjunction with the cloud, but the cloud itself is actually being built up from the Kubernetes layer, and that's a trend that is only going to continue as we move forward. And then finally, as I mentioned, Kubernetes itself is trying to do a better job building itself in a way that makes the cloud providers easier to integrate. Things like CSI, cloud storage interface drivers, are getting better, so we can have storage integrations with things like Key Vault, Azure Key Vault for secret management, Azure Keys for doing custom encryption of secrets. There's a bunch of work in the right places, Azure CNI to do network integration, ingress providers for the Azure application load balancers. A lot of work is being done to add
Okay, thanks, Brandon, for the great talk. Thank you. So as Brandon just mentioned, that all the cloud providers are now working on the project called out-of-tree cloud provider. So what is out-of-tree? What's the difference between the in-tree and the out-of-tree cloud provider? Here's a simple diagram shows that the above one is currently in-tree cloud provider, and the below one is the out-of-tree. So with in-tree cloud provider, all the cloud provider code are built within the binary of kubelet and kube controller manager. So you would say that the node register, the credential provider are built within the kubelet binary. And for some controllers, for example, the service controller, the volume plugin, the service controller, they are built in with kube controller manager. So when you run cluster on the Azure, you would configure the cloud provider to Azure for kubelet and the kube controller manager. With out-of-tree cloud provider, we're moving those components into different binaries and running as different pods in the cluster. So now, with out-of-tree, kubelet and the kube controller manager would run with cloud provider set to external, and we would run a separate control plane component called cloud controller manager, so which would be in charge of node lifecycle, the service controller, and also the root controller. For persistent volume plugins, a disk and a file, we would move to CSI drivers. So 2 new components would be introduced to build the CS drivers for them. For credential provider, C cloud provider is working on CAP to extract it also from the cloud Kubernetes. So it is still not ready yet. Also, the last component is about the cloud node controller. So this is what we are working on to use the instance metadata service to initialize the node. So we have created a CAP and have been discovered in C cloud provider. We have also implemented the POC in cloud provider Azure repo. We have integrated that with AKS engine, so then I would demo that later. For CS drivers, we're also working on Air disk, Air file, and blob field CS drivers. They have been reached beta version on Linux nodes, and they have been integrated into AKS engine. For Windows nodes, there are still some issues that we are working on. For external credential provider, there is a CAP already proposed. There are actually several ways to extract the credential provider, but it's actually not ready yet. So it still needs more discussion which way would we choose. So we're hoping that more progress will be made in the next release cycle 1.18. OK, now it's demo time. I would demonstrate how to provision a new node with out-of-tree cloud provider, how the node is initialized, and how do we use the CS drivers for a disk and a file. OK, because the cluster provision would require a lot of time, so I have already provisioned cluster, but I would show you how we chose Cloud Controller Manager. So it simply enable the use Cloud Controller Manager in the AKS engine manifest, and we also configure the profiles for master and node. So it is a simple enough cluster that with one master, 2 agent posts, each agent post would contain 1 node. So this is the nodes we have got for this cluster. OK, we will have 2 nodes and 1 master node running in this cluster. And we also have deployed multiple components on this cluster, so we could check the pods on this cluster. So you would see that we have already deployed the master component, the API server, the controller manager, the scheduler. As we also enabled out-of-tree cloud provider, we also deployed the cloud controller manager and also the cloud node manager daemon set on each node. For persistent volumes, we also deployed the CS drivers for Air disk and Air file. So this is all what we need for the out-of-tree cloud provider. Okay, so to demonstrate how the node is provisioned and how the node is initialized, let me first delete a component called Cloud Node Manager. So I have a manifest for the Cloud Node Manager. It's generally a daemon set running on each node. It will tolerate the node execute and node scheduler turn. So we could delete it first. Okay, the daemon set is now removed. So now let's scale the cluster. So this is the Azure resources after I deployed the cluster. So a lot of resources are listed here. So the virtual machines for master, the virtual machine skill sets for 2 different node pods, the public IP addresses, as well as other resources such as security groups, the root tables, the virtual networks, and so on. So to create a new node is simple enough to scale the virtual machine skill sets with new instance. Now let me scale the cluster to 2 nodes for node pod 1. Okay, then we switch to instance list. We would say that a new node is in provision state. So the new virtual machine creating would require about 2 minutes. So we need to wait a while for this. While we're waiting, let's check how the components are deployed within this cluster, how they are configured. So this is VS Code. I have already installed the Kubernetes plugin so that we can interact with the cluster directly within the VS Code. So we have a new nodes list here. We have workloads. We have namespaces. So the system components are deployed in the Kube system namespace. So let's switch the namespace first, and then list the pods there. Okay, then let's check the config options for Kube Controller Manager. We would say that the Kube Controller Manager is running the cloud provider with external option. So this means a separate cloud controller manager is required to configure the cloud provider back to Azure. So this is the cloud controller manager pod here. So it have configured the cloud provider to Azure, as well as other options such as cloud config file. There is also a cloud node manager as a daemon set, but we have just removed that at the beginning of this demo, so I would show that later. Okay, there are also SafeDrivers for Azure Disk and Azure File. So there are generally some deployments on the cluster. Okay, there are multiple containers in the SafeDriver. Now, let's see how could we use the SafeDriver to create a new pod with persistent volume. So I also have a demo file here. So to use the SafeDrivers, we first define a new storage class and set its provisioner to disk.csi.azure.com. So this is different from the current default entry Azure Disk file, Azure Disk storage class. And then we create a PVC referring this storage class, create a pod referring this persistent volume. So within this demo pod, I also created a init container which would write a file to the Nginx index files. So then when we access the Nginx, it would show the string Azure Disk here. Then I also created a service. So now let's create the service. So we could generally create with a command line integrated in the VS Code. Before creating, so we just have switched the namespace to Coop system. So let's switch to the default. Okay, now let's create the resources, and we would find that the PVC has been in provisioning state, and if we wait a while, a PV would be created in a few seconds, and then the PV switch to the bound state. If we switch to the pod, then the pod would start to initialize. So the initialize is mount the air disk to its local file system and write the index with a string air disk. So because this is actually a new air disk, on the node, Kubernetes need to invoke a disk driver to format the file system, so it would need a few seconds to initialize. Okay, the pod is now in running status. If we check the file system, so we would find that a new volume here is mounted in this container. And we also deployed a service, so the new public IP should be allocated. If we access this public IP, we should find the output should be air disk. So this is a simple demo running Nginx with air disk CS driver. Then now let's back to the node. So the node is now, the virtual machine is now in running status. If we check the node list, it should be in running now. So let's list node again. Oh, sorry, it is node. Okay, this is the new node will have been created. It is in ready status, but is it really ready to running the new workloads? Actually not. Let's refresh the node list here. We would find more details here. So this is a new node here. Okay, so for this node, there are some tags on this. The tag is called cloud provider uninitialized. This means the node has been created and has been joined the cluster, but it is actually not ready yet because the cloud provider doesn't initialize it yet. So we need a different component to initialize this node. That is what the Cloud Node Manager runs. So let's create the Cloud Node Manager back again. Okay, the Cloud Node Manager is now running on all the nodes. And let's check the logs of the Cloud Node Manager running on the new node. So the new node is VMSS file. And this pod is running on the node file. So we could check the logs. Now we see it. So it is adding the new node labels with the intent type. It also initialized the node with the fault domain and its region. It also initialized the node with its provider ID. So if we back to the node list and refresh its manifest, we would find that new labels are added in the node labels, and also the provider ID has been initialized, and there's no tags on this node. So now it is actually fully ready to run the workload. Okay, this is a simple demo for the auto tree provider. So some of you may consider, so how could you get involved if you have some issues or have some proposal or have some feature? There are actually several ways to do this. So you could join the meetings, regular meetings. You could join the Kubernetes Slack in channel provider Azure. You could get involved in discussion about caps in C Cloud Provider. You could also grab issues from the project board we maintained in the Kubernetes project. OK, that's all for today.